Have you ever wondered what it would be like to play with your favorite toys in space? Imagine floating around with no gravity pulling you down. Would a ball still bounce? Could you build with Legos? It's a fascinating question that gets you thinking about how the world works. We are so used to gravity, that invisible force that keeps our feet on the ground and makes things fall. But what happens when you take that force away? The International Space Station, or ISS, is a giant laboratory orbiting our planet, and it's the perfect place to find out. Astronauts up there aren't just doing serious experiments. Sometimes they use simple, fun objects to explore the fundamental laws of science in a truly unique environment. This very question led NASA astronaut Don Pettit to do something amazing. Before we blast off to see the yo-yo in space, let's remember how it works right here on Earth. When you hold a yo-yo and let it go, gravity is the first thing that kicks into action. It pulls the yo-yo downward, causing it to fall. As it falls, the string unwinds, and this is where the magic really starts. The act of the string unwinding forces the body of the yo-yo to spin. This spinning motion is crucial. It's not just falling, it's falling with a purpose, converting the potential energy it had in your hand into kinetic energy, the energy of motion and spinning. This is the first step in any yo-yo trick you've ever seen. The spinning is what gives the yo-yo its stability. Think about how a spinning top can balance perfectly on its tip, while it would just fall over if it wasn't spinning. The yo-yo works in a similar way. This rapid rotation creates something called gyroscopic stability, which keeps it from wobbling all over the place as it travels down the string. Now let's talk about the secret ingredient that makes a yo-yo work even without gravity. A law of physics called the conservation of angular momentum. It might sound complicated, but the idea is actually quite simple. Angular momentum is just a measure of how much an object is spinning. The conservation part means that once an object starts spinning, it wants to keep spinning at the same rate unless some outside force acts on it. Think of an ice skater. When she pulls her arms in, she spins faster. When she extends them, she slows down. She is changing how her mass is distributed, but her total angular momentum stays the same. This principle is everywhere in the universe. It's what keeps the Earth spinning on its axis and what keeps it orbiting the Sun. In space, where there's no air resistance to slow things down and gravity's pull is balanced by orbital motion, this law becomes even more obvious. For the yo-yo, this means that even though gravity isn't there to pull it down, you can still give it a push. When Don Pettit finally performed his yo-yo experiment, the results were even cooler than you might imagine. He started not by dropping the yo-yo, but by giving it a gentle push away from his body. Instantly, the yo-yo sailed forward, its string unwinding and its body beginning to spin rapidly. It reached the end of the string and just hovered there, spinning perfectly. Without gravity to pull it back or make it dangle, it floated in place like a miniature tethered satellite. This was the conservation of angular momentum in its purest form, a beautiful and mesmerizing sight for everyone watching back on Earth. He then demonstrated a classic trick called walking the dog. On Earth, you let the yo-yo spin along the floor. In space, he just let it spin at the end of its string for a long, long time. It seemed like it could spin forever. Next, he tried the sleeper, where the yo-yo spins at the end of the string. In microgravity, the sleeper was incredibly stable and long-lasting. He could let go of the string, and the whole system would float together in the cabin of the ISS, perfectly preserved in its state of motion. So what does a simple yo-yo spinning inside a space station really teach us? It teaches us that science is not just a collection of facts and formulas in a book. It is a description of the reality we live in, and it's a reality that can be explored through curiosity and play. Don Pettit's experiment brilliantly bridged the gap between complex physics and everyday fun. By using a toy, he made concepts like angular momentum feel intuitive and exciting. He showed us that the fundamental laws of the universe are consistent, whether you are in your backyard or orbiting 250 miles above it. They just manifest in wonderfully different ways. This experiment also highlights the importance of human creativity in science. Sending a yo-yo to space might seem trivial compared to launching a multi-billion-dollar telescope, but its value is immense. It inspires the next generation of scientists and engineers by making space feel accessible and relatable. It encourages kids to ask, what if? and to see the world around them as a laboratory full of amazing things to discover. Play is not the opposite of learning. It is one of the most powerful ways we learn. It sparks our imagination and pushes us to test the boundaries of what we think is possible. Furthermore, these simple demonstrations in microgravity have practical applications. Understanding how objects spin, move, and react in space is critical for designing spacecraft, deploying satellites, and planning for astronaut spacewalks. In the end, the story of the yo-yo in space is a story about the human spirit. It's about our endless desire to explore, to understand, and to share that knowledge with others. Don Pettit's yo-yo reminds us that the final frontier is not just a place for machines and serious experiments, but a playground for the human mind, where a simple toy can unlock a deeper appreciation for the magnificent cosmos we are all a part of.